Welcome to week 4 Pythagorean Theorem part 2. Again, today we're going to be looking at what is the relationship among the legs and the hypotenuse of a right triangle. So looking at the warm-up, the first thing we're going to look at is the square root of these two numbers. So the square root of 49 is a perfect square. So you're looking at what times itself is 49, and that would be 7. Now it could be a positive or a negative 7, because when you square 7 times 7, it's 49, but also negative 7 times negative 7 is also 49. B, notice we have this approximation symbol. So approximately, what is the square root of 200? So if you have a calculator, you're just going to type in 200 and then click that square root button, and you're going to find that it's approximately 14. You can round this off to 14 or 14.1. Let's use this answer to the nearest tenth. So again, it could be a positive or negative 14.1. On the next section, we're looking at the Pythagorean Theorem, taking our formula that we used yesterday or in the last video to find out if a triangle is a right triangle based on the side lengths. And we can use a Pythagorean theorem to prove this. And we said that a squared plus b squared equals c squared. And in this box it says the inverse of squaring a number is the square root. So it's the square root of a number. So when we're looking at our legs, remember the two shorter sides that are attached to the right angle are our legs, and opposite that right angle is going to be our hypotenuse. So let's set up this first problem. We have the lengths of the two legs, which is 24 squared plus 18 squared, and that's going to equal c squared. Sorry about the 5-year-old. So we're going to take 24 squared. You can use your calculator, follow along. 576, check the math. And 18 squared is 324. And again, we don't know what the hypotenuse is equal to yet. Excuse me. Simplify. The sum is going to equal 900. And this is where we want to use our inverse operations to solve for what c is equal to. So the next step here, we're going to take the square root of 900 and the square root of c squared. So this I already know is going to equal c times c, square root of it is c, and then 900 squared. So you can use a calculator again if you'd like. The square root of 900 is 30. And again, it's going to be a positive or negative 30, because regardless of it being a positive or negative, it's going to give you a positive answer. So our answer here is 30 is equal to c. So our side length, because it's a triangle, we need a positive answer. Our side lengths are 24, 18, and 30. And then double check your answer. So when we're looking at the two legs, these two legs should be shorter than the hypotenuse. All right, so on the next page, let's try another one. So for B, now this one's set up a little bit different. Our triangle looks like it's flipped upside down. And we have a triangle that has side lengths of 3, 8, and B. Now again, we're looking for which is our hypotenuse. And opposite the right angle is that 8. So when we set this up, we have 3 squared plus b squared equals 8 squared. I'm sure that's crooked. So go ahead and work this out. 3 times 3. Bring down the b squared, and 8 times 8. And then this becomes, once we've simplified, basically a 2-step equation. Doesn't kind of look like the one we're used to where we have that multiplication, but we do have this square that we have to simplify. Let me fix this. High tech here. So the next step is we need to move everything away from our variable. So we're going to subtract 9 from both sides, so that we're left with, on the left side, just b squared. And that's going to be equal to 64 minus 9 is 55. And then that goes back to what we just said on the front. We need to find the inverse of squaring a number, which is the square root of a number. So we're going to, the square root of b squared is b, and the square root of 55. Now 55 isn't a perfect square. So we're going to have to approximate it. And the approximation here is going to be either a positive or negative, and it rounds off to 7.4. So the side length here is not going to be a negative 7.4, but a positive 7.4. And again, double check, the 2 legs are shorter than the hypotenuse. All right, let's see. So again, we have another triangle. It's not sitting on what appears to be the base, but it's sitting on, or a leg, it's sitting on its hypotenuse. So these are the 2 shorter sides. So let's set this up, and it gives us a. So let's go ahead with a squared plus 17 squared is equal to 20 squared. From here, we want to simplify. So we have a squared plus 17 squared, which is 289. And then 20 squared, 2 times 2 is 4. Add your 2 zeros, it's 400. Next, let's subtract the 289 so that we can move everything away from our variable. So this is 289. I'm going to subtract. So on the left, we're left with just a squared. And then on the right, we have 111. Next step, opposite of square root, opposite of square is the square root. Let's find the square root of a squared, square root of 111. Do you think it's a perfect square? No. All right. So we're left with a is approximately, because it's not a perfect square, it's going to round off to a positive or negative. Did you find it? 10.5. And again, because it's the side length of a triangle, we're going to use the positive value. And check yourself. Check your work. So 10.5, 17, and 20. The 2 legs should be shorter than the hypotenuse. You can always go back and resolve it. Square 10.5 plus 17 squared, and that should be really close to that 400. Right, at the bottom, we have Pythagorean triples. Now, these are sets where you're going to find that they're perfect squares. So we're not going to have any of those rounding types of problems. That being said, if you find that your answer is not coming out to be a perfect square, then go back and check your work. So we already did this one at the beginning, the 3, 4, 5. And these are going to be our leg, and hypotenuse. So it's going to go leg, hypotenuse. I'm not sure if it's the right direction. But. So we know that 3 squared, we said, was 9. 4 squared is 16, and 5 squared is 25. So 9 plus the 16 does equal the 25. 3 squared, 4 squared, 5 squared. So see if you can come up with the next one. So here, this is where we're going to have to do some subtraction to figure out that missing number. So again, 6 squared, 36, 10 squared is 100. So to figure this out, 100 minus 36 gives you what? Did you get 64? And then the square root of 64, because that side length can't be longer than 10. So we're looking for the square root of 64, which is, you got it? 8. All right, so try the next one. Now the next one does give you the leg, and you're looking for the hypotenuse. It's probably the easier one, but because we don't have to do any subtraction here. So let's take a look. 9 squared. 12 squared. Add them together. Find its square root. I'll give you a moment. You can pause it. It's probably easier if you just keep playing it. 81 plus 144 gives you, did you get 225? And the square root of 225 is 15. All right, try the next one. Again, you can pause it. Challenge yourself. 5 squared. I don't have 13 squared off. I think it's 169, I'm pretty sure. Ooh, I think we did this one. Yeah. Gives you 144. You're like, how is that possible? Well, you take a look at the 2 legs of the 9, 12, 15, and the hypotenuse and that leg. They're not the same. But we do get to use that 12 again. So 5, 12, and 13. All right, last one. You have 15 squared, 17 squared. Find your missing number. Give you a second. I'm not even working this one out pink. Let's see if you got it. Did you get 8? Hope so. All right, if you have any questions, please make sure you're going to message me. And there are some practice problems. And if you want to try those out, this is how you initially set up the first page. And then there is a third page, excuse me, the fourth page has some more that I'm not going to set up for you. But again, the two legs is equal to the square of the two legs is equal to the square of the hypotenuse. I'm just going to kind of move these up. You can pause it as you need. And that last one with Troy that's driving 8 miles due east, then 5 miles due north. How far is he from his starting point? So we're looking at the distance Troy is from where he begins to where he ends. And if you notice, and we'll get in this to this next video, is using the Pythagorean theorem for the distance formula. And we've already kind of done this at slope. Notice this is our right angle. If we think about this like our coordinate plane, this is our rise, this is our run, and this is the slope. It's the distance between those 2 points. So next week, really nothing new. Just a little tweak using squares and square roots, all right? Again, if you have trouble, give me a holler. And hope to see you in the next Zoom. Bye, guys.